this unit, we're going to start with line graphs or bar graphs in this case. Let me zoom in. Let me zoom in here. That way we can see a little bit better for our graph. What we're looking at here it is you have two values. You know, we're going to compare two things. In this case, the years, that's what it says here. And then over here, spending in dollars. All this information is per capita spending on healthcare. So if we want to know how much was spent in 2004, I'm looking at this 2004 here. See how it's 6,000, and that's basically where the line ends. So I'm gonna say in 2004, the spending on healthcare per capita was about $6,000. Now, if I want to move ahead, let's say I want to look into the year 2009. 2009, it goes a little more than 7,500. So my answer will be a little bit more than 7,500. Unfortunately, in bar graphs, we don't know exactly how much more. So if we say 7,530, 7,560, or 7,550, somewhere around there, that's what this bar graph tells us. So we're comparing years and we're comparing spending in dollars. So this is what we call the bar graph. So the first questions in your homework is going to be about that. But then we also move into line graphs, kind of like the bar graphs. Line graphs are kind of like the bar graphs, but instead of doing the bar all the way up, we just put the point that is on top of the graph. So what I mean with that is imagine like a bar graph, imagine something like this. Notice how the point that I'm putting, it's the point at the very, very top of the bar graph. So that's the similarity between line graph and bar graph. So the point is just the top of the bar. So now here it is, the average US gasoline prices. So if I want to know how much was it in 2004, which is the first number here, the price was about $1.87, probably $1 and something. I know it's more than 1.75 and it's less than 2. So that's what I'm saying. It's $1.80 something. Now, if you want to look back in 2011 when the prices were really high, 2011, if I look up, it was between $3.50 and $3.75. Seems like it was about the middle. So I'm gonna say it's about $3.60 something, right? So once again, kind of like bar graphs, line graphs don't give us an exact value in some cases, but they give us a really, really good value on where things are. So, and then the reason why we use line graphs sometimes, because we can connect the points, and just at a quick glance, we can see that prices were going up, 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 then they dropped, and then they start going up and up again. So just for us to be able to compare things for later. So once again, you guys on your homework, you guys will see some graphs. You guys will have to answer things from there. But now let's take a look at other examples. Decide whether each order paired is a solution of the equation. So we're going to use the equation 2x plus 3y. Notice how I have two variables, x and y. So I'm going to give you two values. The first number is the x value and the second number is the y value. So all I want to know is, do these points, these values, if I plug them in there, would it give me a true statement? What I mean with that is, if I get 2 times 3, hold on, this thing froze for a minute. Let's see. Gotta love technology only sometimes. Sometimes it freezes. So we have, remember, all I'm doing is I'm replacing the values with the values given. So instead of x, I'm gonna write 3. Instead of y, I'm gonna write 2. So once again, 2 times 3 plus 3 times 2 is equal to 12. Once again, notice I copy my same statement. 2x plus 3y equals 12. It's just I replace the values of x and y. I know in multiplication, when there's multiplication and addition, according to the order operations, remember PEMDAS or GEMS or wherever you guys saw it. So we have 6 plus 6 because we have to multiply before we add. 6 plus 6 is equal to 12. You know, is that a true statement? Yes. So in that case, 3 and 2 is a solution to the equation. Notice that we're calling it a solution, not the solution, because there are infinite many numbers that could make it true. So question is this a solution? Is this one of them? In this case, yes. Let's take a look at this other example. This is my x value. This is my y value. I'm using the same equation. So I'm going to go 2 times negative 2 plus 3 times negative 7. And I'm going to see if this is 12. I know in multiplication, 2 times negative 2, this is negative 4. I'm going to use parentheses so just we know it's a negative, plus a negative 21, right? 3 times negative 7 is negative 21. And then it says this is 12. I know negative 4 and a negative 21, that's negative 25, which is not 12. So I'm going to say, no, that's not a solution. So all we do when we get asked, is this a solution? And we're given the values for x and y, just plug them in there. And then see if you get a true statement or not. Now for this, we're going to complete it. We want a solution. We want the two values, the x and y, that will make that statement true. But from the two values, the x and the y, we're going to give you one. We want you to solve for the other one. That's why we learned in chapter 2 how to solve for equations. So here, since I'm giving you the first value, I'm telling you that x equals 7. So let me rewrite this equation, y equals 4x plus 5. But instead of x, I'm going to write 7. So I'm going to write y equals 4 times 7 plus 5. And we need to solve for y. So we technically have y equals 28 plus 5. So the value of y should be 33. So that's how I'm going to complete that. Not only can I give you the value of x, like I did, I can give you the value of y. Notice how it's the second value. So here, I'm going to rewrite, once again, the same equation. I'm going to write negative 3 is equal to 4x plus 5 and solve for x. I don't want the 5 there. I'm going to move it to the left as a minus 5. Remember, every time you move something from one side to the other, you switch the sign. So I have that negative 8 is equal to 4x. Now let me divide both sides by 4. So x equals negative 2. Once again, notice that A and B are two different points, right? Two different values of x and y, but both of them are solutions. Remember, I told you guys now when we have lines, we have infinite many solutions. Those are two of them. So that's how we're going to be able to work them. Not only can I give you the values like this in parentheses, you can be given them in tables. You have the equation x minus 2y equals 8. For this first part, I'm going to tell you the value of x equals 2. So solve for y. So if we look at that, we have 2 minus 2y equals 8. Just work it out. And I'm going to move the 2 to the right as a minus 2. So I have negative 2y equals 6. Divide by negative 2. Y equals negative 3. So that's how I'm going to complete that. Then I'm going to be like, all right, since you know how to find the value of x when y, the value of y when x equals 2, do it again, but now x equals 10. So you will go 10 minus 2y equals 8. All right, subtract 10. Negative 2y equals negative 2. Divide by negative 2. Y equals 1. So there. And I'm like, all right, now do it again, but now y equals 0. And then, all right, do it again, but now y equals negative 2. So technically, it's like 4 questions in one. I'm having you guys use the same equation, but 4 different times. Even for my example B, when you guys see only one variable, right, you guys don't see a value of x, I mean a value of y, you only see x, x equals 5. So it doesn't matter what value of y you give me, the x value is 5. So here, this is 5, this is 5, this is 5, right? It doesn't matter what value y you give me, x equals 5. So that one was a little bit easier to work with, but once again, this is how you guys will see it on your homework. Now we're gonna do plotting points. We have to plot in the point 2, 4 on the coordinate axis. So we know that the x value is 2, the y value is 4. Usually the x-axis, this line at right here at the bottom, like this one going horizontally, I mean, we call it x, and most of the time we're going to have a little x there. And then here, going up and down, we call that the y-axis. Usually we put a little y there, just to say this is the y-axis. Kind of like, remember when every time you guys go to a play, like a play, or you guys go to a game or something where you guys have assigned seats. Not only they take you to the section, but once you go to the section, it tells you which row you have to go to and which seat number you have to go to. So it has to do row and seat number. Same thing here. So we're gonna go in rows first, which is the x-axis. I'm gonna go to positive 2. So I'm gonna go here to positive 2. Now on the y-axis, I'm gonna go to positive 4. So it gives me the point here. So I have to go 2 on the x and 4 on the y. So that's the point 2, 4. On your homework, when you start your homework, you're gonna see this big point in the center. You have to drag it to 2, 4. So you have to grab that point and you have to drag it to the correct position. Now, let's take a look at this same example with different numbers, but now we're going to deal with fractions. Now, on the x value, I'm going to go to 3/5. Let me zoom in this a little bit. So my x value is 3/5, and my y value is -2. 3/5 means the 5 means that from 0 to 1, there's 5 spaces, and I want to go 3 of those 5 spaces. So notice how from 0 to 1, there's 5 little squares, so I have to go 3 of those. Now, for the -2, don't go just down 2 squares, go down all the way to -2. So you're looking at this point. Notice from 0 to 1, for between every whole number, there's 5 little squares, and the reason why, because of that 5 at the bottom. If I had a 7, for example, at the bottom, there'll be 7 little squares between each number. So you have to go 3/5. Right? Every time on the x, every time it's positive, we move to the right. Positive, we move to the right. Negatives, we move to the left. So that's why I move to the right. Now on the y's, positives, you go to the top, and negatives, if you see them, they're at the bottom. So that's why my solution, it's right there. So I went 3/5 to the right and -2 to the bottom. Remember, once again, not 2 squares, -2. Okay, now let's take a look at this. So suppose that it costs $18 to place a classified advertisement in the newspaper plus $5 for each line. Then the cost to place an ad X lines long is given by Y dollars, where Y equals 5X plus 18. So far what we were told is we had to pay $18, call that, the fee for paperwork or whatever you wish to call. So you had to pay $18 to begin with, plus $5 for each line. So you see how the value Y is going to be 5 times X, because 5 for each line, plus the $18 that I said it was like the paperwork fee. Now, express an order paired. Notice that I'm saying order paired. So I'm looking at values of X and Y. The fact that a 14-line ad cost $88. Remember, see how the line is represented with X? So I'm just going to say 14, because that's the X value. And then 88, that's the Y value. And that's all I have to do. It looks like an ugly question. Like there's a lot of words. But as soon as we get order paired, I'm asked to do X and Y value. Remember, X is how many lines? So that's what, 14th. Y is the price, the cost, $88. All right, so that's all we do.